Okay, we're at gotomath.com working some calculus. We're actually down here in the related rates section, and I believe if you click on this button there's a number of different problems that'll come up, but this is one. This is one of them. Alright, so this section right here. Okay, this is the actual problem we're going to be working. Same thing coming from section 4 here, I guess you'd say. It says find the rate of change of the distance between the origin and a moving point on the graph of y is equal to 5x squared when x equals 5 centimeters, dx over dt equals 3 centimeters per second. We're going to round our answer to 2 decimal places. So let's go ahead and bring up the whiteboard, and I'm going to first sketch out maybe a picture here of what's kind of what's going on. Help you see it. So we had that curve y is equal to 5x squared, and how about I just write that right here? Y is equal to 5x squared. So let's go ahead and just sketch that out so it looks something like this right here. Okay. All right. Now there's a there's a point here at the origin, and then there's going to be a point somewhere on the graph, and this point on the graph is actually moving. Okay, so it's moving. Now this point stays the same, it's just moving right along. Some of the things that they gave us that we'll need to write down, which I'll just write right here. X is equal to 5, I believe, at x equals 5. So 5 is right here. And to get this exact point right here, we're going to need to know what its y value is, and we'll take that and just plug it directly in right here. Now obviously this graph is not to scale, okay? So 5 squared is 25, and 25 times 5 is 125, so we'll need to know that. 125, and like I said, this is not to scale. Alright, so we have a point here, this ordered pair of 5, 125, and then the origin 0, 0, another point right here. Alright, so those are some things that we need to know. It says find the rate of change of the distance. So the rate of change of the distance between the origin and that moving point. The rate of change between the origin and this moving point. So this distance is changing with respect to time right here. So we're going to need to know a relationship between the distance, right, this distance right here, and that's just going to simply come from the distance formula. That's going to come from the distance formula, and instead of having it square rooted on this side, we're just going to leave d raised to the second power. So if we all remember the distance formula, which is going to come in handy here, difference in x's plus squared plus the difference in y's squared. Okay, so what we'll want to do is take the derivative of this implicitly and with respect to time. Whoa, what just happened there? I don't know. Anyway, so let's just go ahead and do that right now. So I'm going to bring the 2 out front, and then we have d over dt, okay, is equal to, and then bring the 2 out front, and then we have x of 2 minus x of 1 dx over dt plus 2, and then y2 minus y1, and that's dy over dt. And what we'll want to do here is solve for dd over dt. That's going to actually give us the rate. Now we notice we have a 2 in each one of these terms here, and so we can just multiply through by a half all the way across and actually just get rid of those two coefficients. Alright, well, let's take a look at this. We have our two ordered pairs, and we'll just call this x of 1 and y of 1 and x of 2 and y of 2. How's that? And so we have these numbers, dx over dt. Now, they gave us dx over dt. They gave us that, and I will write that just right here. Dx over dt is equal to 3, and that was centimeters per second. And remember, this is, can I sneak that in there? That's actually 5 centimeters. Alright, so we have dx over dt. What we don't have is dy over dt, but we can get that from here by taking the derivative of this with respect to t. So let's just do that. So the derivative of y is 1, but then we write dy over dt, and then that's going to be 10x dx over dt. And then what we'll want to do is just simply plug in 5, okay, our x value here, which is 5, and where are we at, dx over dt, which is 3. Okay, and that's equal to 150. Let me rewrite that down here. So this is dy over dt is equal to 150 centimeters per second. Alright, well, we have everything that we need now. So what we're going to do now is just go ahead and fill this stuff out. And I'm going to write d over dt here. And we're going to go ahead and take this d and bring it down. But let's just go ahead and plug in everything we know here. So x of 2 minus x of 1, so this is going to be 5 minus 0, and I guess I will just write it in like this. And then dx over dt, they gave us that was 3 centimeters per second, and then plus, and then this is going to be 125 minus 0, and then dy over dt is 150. Okay, now down here, this d right here is the distance from here to here. So we've already really done this. We just got through doing it right here, but I'm just going to write it out right here. 125 minus 0, can't see that. And then of course this is all square rooted, and so this becomes 5 squared plus 125 squared, right? And then that ends up, what does that end up being? I don't know, some big number. I think it actually reduces down to or something, but anyway, right, so I'll just write that right here. 5 squared plus 125 squared. Okay. All right. Anyway, I think I'll just stop right there. You can surely work this out. But dd over dt ends up becoming, and we got to round it. Let's actually put some approximations there, but it ends up becoming 150.00, and then there's some other numbers out here. And remember that this is centimeters per second, centimeters per second, because it's distance here, okay? So it's pretty simple. You're given some information, And then of course some things that we're going to need to know, and that is the distance formula, and then taking the derivative of it. And there were some things we had to find. We had to find dy dt, and we had to find y up here, which was pretty easy to do. And that was pretty much it. Um, and if we go back to the website, let me click the answer there, bring it down. Okay, so anyway, now you notice, you remember that the dy over dt was also 150, but this number has actually got some numbers out here beside it, but it was pretty close to the same. So we're in this section here. We're at gotomath.com, and you'll want to practice. We got several different problems actually. Of course I got to go into the script and get them to come up, but we got a lot of different problems about this point, and some other point on the graph, and finding the rate of change of the distance. Alright, so see you there. Bye.